Oh, welcome to another video, and today we're going to be solving educational code forces round 134, and we are late by about 40 minutes. Let's see the first problem. I hope the internet doesn't fail us. Okay, so the first problem is image. You have an image file of size 2 cross 2 consisting of 4 pixels. Each pixel can have one of the 26 different colors denoted by lowercase Latin letters. You want to recolor some of the pixels of the image so that all 4 pixels have the same color. In one move, you can choose no more than 2 pixels of the same color and paint them into some other color. Uh, what is the minimum number of moves you have to make in order to fulfill your goal? Consists of 2 lines. Each of the lines contain 2 lowercase letters of the ladder without any separators, denoting the row of pixels in that image. Print one integer the minimum number of moves you have to make so that all 4 pixels of the image have the same color. Okay. The first test case. Let's open second question also. Let's reload this. Um, so the first test is RVBR. You can paint the bottom left pixel and the top right pixel into the color R, so all pixels have this color. Now the second test is to the second test is to Muzana. Okay. Into B and paint the bottom left to the B. Okay. Third test case, all the pixels already have the same color. Fourth test case, you may leave fourth test case A, B, C, D. You may leave any of the pixels on same and paint all three other pixels into the color. So 3 is the count. With test case, you can paint both top pixels into the color X. Yeah. So basically, what we can do is we can keep a count of the letters inside the strings. So basically, we are inputting two strings, right? String, let's say S1 and S2. So first we import S1. Since these are of length 2, I'm gonna say S1 of, okay, we don't even need to do that. Or do we need to keep a count? Can we do it without keeping a count of the number of letters basically? Uh, I don't know. They just do it by the by this way. So I'm gonna subtract A from them. So now that I get a number between 0 and 26, 0 and 25, and I'm gonna do a plus plus, and I'm gonna do this for every letter. It should be for S2, sorry, S1 for 1, S2 of 0, and S2 of 1. Right. Now that we have the count of every word, so if in one move, no more than 2 pixels of the same color, so I'm gonna either sort A, or what we can do is, since there are only 4 letters, I could have also could have taken a map, and it would have been easier to iterate over a map, but I took an array of 26 because there are 26 letters in the alphabet. uh, yeah, I could have taken a map, but never mind. I'm gonna do this now. A of 25 would have the largest element, and I'm gonna check if A of 25 is equals 1 or 3 or 4. So if it's equal to 4, then I just print 0, and else if A of 24, I guess, sorry, A of 25 will equal to uh, 3. So in this case, I can color two of these elements at once, and uh, the one of this element and the other element that would have been present in the one row. So this case is basically means A and a B. Oh, we can just paint the B to become A. So in this case, I would print 1, right? Else if A of 25 is equals to, now since this element has a count of 2, so let's say the element is A, I don't care if they are AABC or it's AABB, I can just do it in one. So I'm gonna do say 1. Now the only case that is left is, oh, there are two cases left. Okay, now if what if the count is 1? Since since the count is 1 and since it's the largest element, so each one of them is different. So the count will be 3. Is there any case left? Because the count has to be minimum 1. The maximum count cannot be 0 because there are some letters, right? So there is actually no case remaining, and this will solve our problem. So it's printing out 1 1. So it's printing out wrong, 1 1 0 3 1. Okay, the second test case, it's failing on the same list. CCW, weird. So the CC would have a count of 2, and a count of 2 means, oh, the other elements are, okay, my bad. So I can convert these two letters into one of these. So I do have to care about this case. So now I'll have to make another case that if A of 24 is equals let's say 2. If it's equal to 2, then I can just do it in one operation, uh, right? Because I can just take those two and convert it into this one. Else, A of 24 would be 1, and that would mean I would require two operations. That was a pretty good question. Many people would have failed here. And if they wouldn't have given this test case, I would have definitely failed on this one. So good test cases they have created. I'm gonna leave this because I should be good for this one. Let's read this B. Uh, Deadly laser. Okay. The robot is placed in the top left corner of a grid consisting of n rows. Oh, top left corner of a grid consisting of n rows and n columns. So n rows and n columns in a cell 1, 1. In one step, it can move into a cell adjacent by side to the current one. The robot can't move outside the grid, and the cell contains a deadly laser. If the robot comes into some cell that has a distance less than or equal to d to that laser, it gets evaporated. Distance between two cells is this, kind of the Manhattan distance, I guess. Print the it is the Manhattan distance. Print the smallest number of steps that the robot can take to reach this cell n comma m without getting evaporated or moving outside the gate. It's not, if it's not possible to reach the cell n comma m, print -1. Laser is neither in the starting cell nor in the ending cell. Uh, the starting cell always has a distance greater than d to the base. I could use a whiteboard, but um, it's gonna be a mess. I could actually use this code. So T test cases, uh, and we have N, M, SX, SY. So there is only one laser. Cool. So what we can do is we can take the input. Um, so we have int N, M, SX, SY, and D. Oh shit, I can't take input like this. No. So the constraints are that N and M are up to 1000. So a grid of 1000 cross 1000. Uh, S6 can be between N and M, and so on. And D can be up till, so D is less than or equal to N plus M, which means 2000. And what is D? D is the distance. This should be, so basically D is the distance where from the laser where the robot gets evaporated. Okay. So what's the algorithm here? So we have a 2 cross 3 grid. There is a laser at 1 comma 3. How would you imagine it? And the D is 0. So then you can just basically go over it, I guess. This is the grid. Let's take a 5 cross 5 example. And the laser is at 3 comma 4. So let's take 3 from here. 3 comma 4. So at this point. And we have to not go inside a distance of 1 from here. So basically, why am I creating this fabric? Is there a highlighter? So we can't go in this grid, right? So we can basically take this route. We can go into adjacent sides, right? So we can take this, 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 and that would be 8. Okay, 1. Okay, moving one cell is 1. So 1, 2, 3, 4, 5, 6, 7, 8. This one is a viable option. Uh, okay, so let's take a case of 2 comma 3. That would mean an area of this, right? And 1 comma 3 has a laser and 1. So 1 comma 3 has a laser here, and the region is 1. So then you cannot go there. But it was given that laser is neither in the starting cell, and starting cell always has. Okay, so the ending cell can actually have a distance less than d, so it might just be impossible. So we got the case where it's impossible. So if uh, m minus so m is not n, n minus x, absolute value of x, plus absolute value of m minus y, if it's lesser than or equal to d, then we can just print out minus 1. Else we can print out f for now, and let's run this. X was not declared in this code. I don't know what I was thinking. Yeah, so I think that works. Now, this case 2, 3, and the uh, what we call it, laser is at this place, and it has a 0 width, so only this place he cannot visit. So he can just go 1, 2, 3, and that's the. Okay, so I think the answer is always equal to this m plus n, right? So 2 plus 3, sorry, m minus 1 and n minus 1, because you are already here. So it's m plus n minus 2, I guess. 5 minus 2 is 3. 10 minus 2 is 8. Okay, so, but what if there is a square here? Then again, it's possible, right? Because it will always be the same path. If we go from here, or if we go here. Uh, whew, what other thing what could get worse? See, if there is a bomb here with a 1 radius, then we cannot do this, right? So the bomb is either here, where this is the portion it cannot travel into, but then this is possible. And if it's any greater than that, then this would enclose this. And let's say if the bomb is here, and this is the space. Then he can go from here. If the bomb is here, he can go from that place. I don't see any problem here. I don't know. Because the bomb can only be a square, right? But we are just seeing this on a 5 cross 5 grid. What happens if we go on a much bigger grid like this? Now, uh, it still has to cover n plus n minus 2, right? But now if the square is, let's say, the square can be either here, then you can just go from there. I think always you can travel. So this is not a square, but you get the point. Oh, hmm. Can he travel in lesser distance? Four, five, six. Okay, so this takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that would take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I don't see any problem there, but I don't know why it feels wrong. It feels wrong. Why does it feel wrong? Why does it feel wrong? Okay, it is wrong. Hmm. What the fuck did we miss? It's not enclosing this. So the biggest square he can make is, let's call this 5, 6, 7. So the biggest square he can make this is this, a four-sided square that would be this, and here also four-sided square. So in this case he can go here, and he can also make this one, but then you can just go from here. He can, what else can he do? He can make a this big square also. Yeah, that's nah. Can he? So it's a 5 cross 5 square. What? He can make this square, and now it's basically blocked. Fuck. So there is more to it than I ever imagined. So what could be the condition? So condition could be if the square's size is what covering basically. So if Sx plus what do I say now? D is greater than or equal to the maximum x and Sx minus D is less than equal to 0, uh, then we see out minus 1 and we do the same for y as well. So if y oh, I guess I'll have to try it for 7 comma 5. So I'm gonna create a test case myself. So that would be 7 5 and the square is located at which position? 3 comma 4 again, and the size of it is 1 2. So the answer should be negative 1 for the last case. No, it is not coming out to be negative 1. Okay. Now it should work. Fuck. Uh, hmm. What the actual f? Okay, let's see this again. 3 comma 4 side is 2. Oh, it's 5 comma 7. Square is 5 comma 7. Because we take I axis here, I here, and j here. That's what we do. 5 and 7 still did not work. Uh, so basically we are adding 3 to 2, and if it's uh, basically adding 3 plus 2, and if it's greater than equal to 5, oh okay, if it's greater than equal to 5, then it's basically covering this whole axis, this whole axis, and for this also. For this 3 minus 2 would not suffice. I mean it would suffice, but then we would have to check for if it's 1, right? If 3 minus 2 is equal to 1, should be 1 here, should be 1 here. So this might be a fluke. Okay, this looks good to me. What do you guys say? I'm gonna submit this anyway because I'm pretty popular anyway. This time I'm gonna say, well, look at this one. Oh shit, there's more to it. What the, what fuck do they want us to do now? So for this, I've already said that this is lower than this, and so it cannot cover this one because we have already checked that here. Oh, maybe this is wrong. So let's print this out. So I'm trying to print out the distance from the point of laser to the point of ending. Why do I not see any? Okay, so it's printing out only when it happens. We can actually analyze that also. So it prints out 1. So is the distance 1? So it's 2 comma 3, and it's situated at 1 comma 3 here, and it's having a distance of 1. Yeah, so 2 comma 3 is having distance of 1 with this. So that is correct. Uh, Now we are fucked. What, man? This is correct. Hmm. Oh, this is incorrect. Because we have to check individually. But how is this yielding out correct for this? So, how is the distance 1? Oh, because the 3 is same. Yeah, so we just have to check if this is less than equal to D, and else if this is less than equal to D, because in both cases the answer is -1 because the bomb is enclosing the the laser is enclosing the last step, so we cannot reach it. So I'm was printing some full stuff. That's how you debug. But I don't know what the fuck just happened. How am I getting an answer of? Oh, I just got wrong. I need this now. Uh, so this is not what I'm looking for. Or maybe I was correct the first time. I was correct the first time. Was I? Because let's say uh, at this point there is a bomb, and this is the circle. Sorry, square. Let's say this is the bomb, and your ending point is here. So then the distance should be, uh, even though d is equal to 1 here, it's covering it, right? Oh, so our deadly laser covers only this plus sign and not that shit. So this covers only this. I got it. So that means our algorithm was correct earlier on. So then what's the problem? Because for this guy, x1 minus x2, x1 minus x2 would be 1, and y1 minus y2 would also be equal to 1, and the sum would be equal to 2. So it does not cover that area. So it is not even a square. Our whole life has been a lie. So then this thing is wrong. So I'm gonna take this back. Come on, give me my solution. Copy it, paste it here, paste the input there. Now I'm gonna check. Uh, for what? Sx plus d. Okay. It's gonna cover an area like this. I don't know how would that change the answer though. Like you would still go from here, right? And if this one is closed, then you would go from here. And if both are closed, then you return -1. I don't know how that makes things. Oh, wait. Oh, okay. So, if let's say the upper one is closed, sorry, the downwards is closed, but then this is also closed here. But then you cannot go right. Yeah, so I missed this part where this is -1. Okay. So when is it -1? So this basically means that our Sx plus d is less than equal to uh, is greater than equal to n, and sy plus d, or can I say for this case also such a case, right? Because in this case also it's called that. It's like, why is it printing out -1? That's weird. Okay, sy minus d. I love, I love, I love you. I mean, it's not. Oh, -3 fuck. We just got fucked again. Okay, that's bad. This is. Oh, fuck. What the fuck? Typo? How can this be possibly be a typo? Now it'll say you have to wait for 5 seconds before submitting. Was it a typo? Imagine. if I would have spent half an hour just for a typo. It has got to be accepted. This better be good. Yeah, 8,337. Not bad after starting literally 40 minutes late. Let's try this one. Okay, let's see standings of what? French standing. Okay. Sharma ji is next level. Okay, none of my friends are participating. Nice. Min max array transformation. You're given an array. I hope my sound is audible. What a great time to check it, right? After the whole video. You're given an array. Min max array transformation. You're given an array which is sorted in non-descending order. Couldn't they just say ascending order? So non-descending means 2, 2 can come. 2, 2, 3. Because that's not ascending according to them. You decide to perform the following steps to create an array B. Uh, Create an array D consisting of n arbitrary non-negative integers. Set Bi is equal to Ai plus B. What the fuck is this? Create an array D consisting of n arbitrary non-negative integers. Set Bi equals to Ai plus Di for each Bi. Sort the array B in descending. If given the resulting array B, for each index I calculate what is the minimum and maximum possible value of Bi you can choose in order to get the given array B. Note that minimum DIs are independent of each other. They can be obtained from different possible arrays D. So, what they're trying to tell us is that so first let's just take the input. So we have the length of the arrays A, B, and D. Uh, the length is same, of course. So now first we get A and then we get the B. Input. There is at least one way to obtain the array B from A. Choosing an array D. Okay. First you have to print dmin for every I, and then we have to do dmax for every I. So all dmin and dmax values are independent of each other. Uh, in other words, for each I, dimin is just the minimum value among all possible values. Let's see a test case. First, if in order to get dimin 5, we can choose, for example, d is 5, 10, 6. Then b is 2 plus 5, 3 plus 10, 5 plus 6, 10, 3, 30, and this. Okay, got it. Got it. So this gotta be D. How much time am I left with? 28 minutes. Can I solve this? Because if I can't, I'm just wasting my time. 3,000 people have solved it. Can I solve this in 30 minutes? Or can I see problem number D? Okay, let's try to solve this. So we have to make array B, right? So what we can do is we can, for finding a minimum for I, we can hope we can store we we can hope that we can store the minimum element in B at this version, right? So what that means is since everything is non-negative, uh, we can only add, right? Yeah. So first I'm gonna calculate. We are given B, right? So I'm gonna calculate the minimum. Or I could just do another for loop instead of doing this shit. Uh, right? Please ignore the variable names, or let's just correct that. It should have been maxi b, but never mind. So now that we have the count, basically we have the numbers that are the maximum and the minimum in array B. Now let's say the minimum number was 7, and the current number that we have in AFI is equal to, let's say, 5. Then we can put a D equals to 2 here, and oh wait, we have to minimize the D. So we actually have to minimize BI minus A of I. So the minimum of this, such that we can make other elements, right? So this would be minimum when BI and AI are the closest to each other, and that means uh, okay, what's the closest number in BI greater than A of I? Closest number in BI, closest number to A of I in B of I that is also greater than A of I. This thing. first thing this, and we also have to check for uh, that other elements can be made, right? So for that we can just check. What can we check for that? I think what we can do is, let's see the test cases: 2, 3, 5, 7, 11, and 30. So for this they have given an answer of 5, 4, and 2. Okay, so closest to 3 is 7, of course. Closest to 5 is also 7. And all of the other elements can be made via putting something, right? And for the largest element, what's the largest? 11, 10, and 8. So largest is 11, 10, and 8. So they have tried to make 230. That is possible. And cause that is possible because both of these elements were smaller than both of these elements, right? So if this would have been let's say 12, so now we can make 7 from 3, we can make 11 from 3, but we cannot make the other number. If we choose, let's say, 7 to make from 3, so then we cannot make 11 from this. So for that case we could not have been able to make 2 to be 13, and d max would have probably been something like 11 minus 2, that is 9. So how do I do this? uh, how do I check this? First let's tackle the minimum, right? So for minimum, the minimum of this should always be able to be made the minimum of this, and yeah, right? Because if this was a 1, then we cannot make it. So this is at least greater than or equal to 2. So for the first digit we can safely say that it's the basically it's bi minus ai for the first one. Now for the second one, if we can make 7, we can make 7 if and only if, so this can obviously make 11, and this can obviously make 13. No. Is it obvious? Yeah, since it was possible to make for 3, so I think the minimum is always going to be BIAI. This is my bet. So to check this, I'm gonna say for, because we can always make it, right or wrong. And let's just print bi minus a again so that we can compare it easily. 588. Okay, that's wrong. That is wrong. Uh, will BI and AI be given as sorted? Yeah, they are sorted. Oh, wait. This should have been. Come on. 046. Okay, this has to be A of I. What the fuck am I doing? 542. And for this is gonna be. So this one is weird. How how did it end up with this? Okay. So there are cases where we cannot do this also. Since we cannot make 2 to be equal to 1. So this isn't possible. How do we check when it's possible? One condition is that if this is a valid thing anyway. But what if this isn't? Then what do we do? What comes there? Plus, is it the only condition we need to check? So what if I place 2 here? But then we cannot make this string, right? Because I can definitely make this to be equal to this. Then the answer is 0, the daemon. But then can I make all of these? Yeah, I think I can make these. But what if this is a 2? Sorry. Yeah, that is the case. First of all, this if else should have been gone inside the loop. if max b is greater than equal to a. So this condition is not enough because in this case you can see that we can reach 4 here by adding this, but then we won't make it to the string, right? So for this, we need to check an a of I plus 1, uh, sorry, b of I. So when we come here, then the maximum, why didn't it break? Because I'm accessing an index. What the fuck? Why does this C++ not code not break? I'm trying to access my nth element which is not even present. Oh, okay, maybe this would have been uh, false here, but this is not false for this case. 4 is true. This is not false. Right? Yes. I is this should work. Now this should work, not this alone. But how the fuck did it? That's bad. Because then now I don't know what's right and what's not. Okay, was it accessing garbage value then? So this is what I meant. I can still see some numbers there that are wrong. 45 and 35. So these guys think that a 10 can be increased to 55, which is not true, right? So I'm checking if a of I plus 1 is less than or equal to. So this guy can make this guy can make this, but this guy cannot make this for this to become this. So this guy also needs to be smaller than this. Ah shit, here we go again. So what we can do for that is, not while true, or maybe while true. So what we are trying to do is, if this guy can replace this thing, then we go interchange with this. And if this guy can represent this thing, I'm gonna I plus plus. Uh, hmm. So we are finding for maximum, right? So this should be int min. Now this is wrong, and it isn't printing it. Okay, for this case, let's go over this case. So 20, can we make, uh, what the fuck is 15 doing here? Okay, okay, okay. What the fuck is 15 doing here actually? That's pretty weird. Uh, oh, nah, that doesn't make any sense. Uh, and why is it printing out garbage values? Weird stuff. Okay, so I think we cannot solve this in 2 minutes. Yeah, that's gonna be it for today. If you want, you can continue to watch this shit. Okay, the answer can actually be equal to. Hmm. What about this case? What is happening here? So it's printing out 23 for this. And then it stops. And what? And now what? What's happening here? Because it has to print something. How the fuck is this not printing anything? Ah, I could actually move it inside this block, but what difference does it make? Nothing probably. Okay, it should be n minus 1. Thank you. Uh, Wait, it's still found. So my approach was that ideally this guy is making this guy is making this guy is making this, and this guy is making this, right? Because both are in ascending order, and that is the approach. So we just have to ask ourselves, can we do better for this guy? Can we do better for this guy? Can we do better for this guy? And if we cannot, like in this case, we couldn't, we just, oh fuck, I got it, I got it, I got it. So I'm actually increasing I here, which I should not. So I'm gonna do something like place replace this with. Just how can it even be 10? How can it ever be 10? There is no 12 in DRA. How the fuck is it becoming 10? I don't understand. Baby, I don't understand this. I'm changing, I can't stand this. My heart can take this damage. Oh, baby, I don't understand. Do you like it rough for me? Do you like it rough for me? Do you like it rough for me? Oh, baby, I don't understand it. I'm changing, I can't stand it. My heart can't take this down. Okay, so this has to be J. Yeah, I think I've done this. Now the only issue is for the minimum. And for the minimum, it's gonna be the same. But instead, what we'll be doing is we're gonna be moving from the last one to the smallest one. So I would try making 5 to be equal to 7, right? So for that, this would look like I would try making 4 to be equal to 1, but it's not. So we cannot make this. So I'm gonna first check like this. If bj, so I can just copy this, right? So it's gonna be long, but the essence is pretty much the same, I think. So we're gonna check if we can, no, but we have to make the minimum difference, right? So minimum difference would actually be for the same number, right? Shouldn't it be? Can't I just display there? We saw that it was wrong, right? We just saw that. No, that is wrong. So, so this number is definitely greater than 5. So you're gonna move to the left. If this number is greater than 5, then we can actually make it right. For 3, we'll have to check for if 5 will make the other numbers. So basically, if 3, 3 can obviously make this, 3 can obviously make this. Can 3 make 7? Because if 3 makes 7, then 2 will have to, yeah, that's possible. And 5 to 39. So I think I've got it. So the answer is basically 5, 2. Or we can make a for loop, which we have to make it. We have to make it. I equals to, sorry, j equals to I, j, sorry, j starts from 0. P of j is greater than equal to p of I. No, we don't have to print. We just have to take the minimum. That would be 2 for loops. And would it pass the time loop? Or we could just give it it's kind of like this one. Actually, it's entirely like this. See if 3 can be made 7. 3 can be made 11. So that is a difference of 8. So now we go minus minus. Now the only problem is time complexity. Uh, fuck this. I could just debug, but I'm not